Hello, everybody, and welcome to this PhD session of the SICSA conference. I am Sushmit Sarkar. I'm the Graduate Academy Director of SICSA, and I have basically the best job in SICSA. I work for and on behalf of the future of research in SICSA. And man, what a future it is. This year, with the very generous support of Amazon Development Scotland, we have the inaugural edition of the Best PhD Dissertation of the Year award for SICSA. And we had a range of fantastic applicants. We had a really hard time picking the shortlisted candidates who are going to give us a quick 5-minute summary of 4 years of hard work. So without further ado, let me hand over the microphone to Chris Cummins, who just obtained his PhD at Edinburgh.
Yes, thank you very much. All right, yeah, thank you so much for inviting me here. I'm very honored to be shortlisted for this award. So I'm a compiler researcher. I like doing compiler research because a compiler is right at the bottom of the hierarchy of needs for software systems. It is the tool which takes the code that we write and it's responsible for turning that into a program that unlocks the performance of our actual hardware. So what I like about compilers is that if you can make them better, everyone benefits, whether or not they know even what a compiler is. So because they're so important, an enormous amount of effort is put into making sure that our compilers are correct and that they produce fast code. So the result of this is that they've grown incredibly complex. We keep adding new features, we keep adding new hardware support, keep tuning the compiler to try and squeeze as much possible performance out of our silicon. So to illustrate the scale of the complexity, if you take a popular compiler like, say, GCC, you just look at the command line options that it exposes to you as to how to optimize a piece of code. There are more configurations for how to optimize a program with GCC than there are atoms in the observable universe. So this is a problem. As we know, the hardware world is undergoing a complete revolution. We hit the power wall. We're now increasingly reliant on accelerators and other exotic architectures. So we need compilers that support this new wave of hardware, but our compilers are now so complex that they are beyond the scope of even an expert to fully comprehend. So the goal of my PhD was I wanted to make compiler construction easy. So my inspiration was that at the time, back in 2016, doesn't that seem like a lifetime ago, deep learning was emerging as this way of expanding the capabilities of machines to reason about natural language in ways that we previously thought were impossible. So my idea was, what if we could adapt that to instead reason about machine language? If we can build a system that can learn to fully reason about programs, then we've solved the compiler problem. So it's an ambitious goal. There's a number of challenges that make this hard, just a couple of them. First is that machine learning and natural language share almost nothing in common. We can represent both of them as words on a screen, but machine languages are non-linear, they're recursive, they have this incredibly rich structure which describes the semantics of a program. And secondly, compilers need to be correct. While for, let's say, some natural language cases, there is an acceptable margin for error. For example, like Google Translate can still be useful without being word perfect. A compiler has no margin for error. If a compiler makes a mistake, the consequences can be catastrophic. So my thesis describes the contributions that I made towards achieving this goal. So to pick a couple of examples, one of the things I showed in my thesis was the first end-to-end system for learning optimization heuristics. So optimization heuristics are the thing which determines for a piece of code how we should optimize it. And they are a total black art. They are tuned currently by trial and error and an enormous amount of domain expertise from very, very clever compiler engineers. But what I showed was that it is possible to learn these heuristics entirely from data without having to know anything about how the compiler is built or even the rules of the programming language. So the benefit of this is that it frees compile developers from having to worry about tuning their compiler. And to boot, it does a better job than humans do anyway, so it's free performance. Secondly, I showed that it's possible to generate tests for compilers entirely automatically. So testing compilers is hard because there are an infinite number of programs. The difficult bit is trying to figure out which programs are likely to produce meaningful results and which will find bugs. So I built a system which treats the entirety of GitHub as a dataset on which a model is learned for how humans write programs. So by using this model, I could generate an unbounded number of new programs which look like they were written by humans. At the time, I think this is still true. It was the only compiler tool which passed the Turing test. But it turns out that generating an infinite number of human-like programs is very effective at finding compiler bugs. So I spent a couple of months of my PhD doing nothing except filing bug reports for compiler engineers, much to their annoyance, I'm sure. Thankfully, now there's a couple of companies that I know of. There's Codeplay in Edinburgh, and there's IBM that have adopted this methodology so that they can write their own bug reports and save me the hassle. But yeah, hopefully that's just given you like a very brief taste at what I think is the remarkable capability for deep learning to address some of the biggest challenges that we face when building optimizing compilers. I'm very fortunate now to have joined a research lab to continue doing the work that I started my PhD, surrounded by the smartest people I have ever met. Finally, I want to thank my advisors, Hugh and Pavlos, for their excellent supervision. And I guess what I'd like to say, just given that we're in this crazy, uncertain, socially isolated world at the moment, if there are any PhD students on this call, stick with it. Getting a PhD was the most rewarding experience of my life. I hope it will be for you too. Thank you so much for listening.
Thank you so much, Chris. And that was a really good message. PhD might seem a hard and long journey, but there is light at the end of the tunnel.
Yes, it is hard, but worthy, I think.
There's time for a couple of questions. You know, the question interface that probably you've been using all morning. I'll get one to get people started while people think of questions. What's next for the field of deep learning in compilers? Great.
Yeah, the good thing is there's a lot to keep me busy. And not just me, actually, thankfully, lots and lots of people. So what I showed in my thesis was basically taking natural language style approaches and applying it to the new domain of machine languages. And this showed, you know, the benefits of it, I think, are very clear in terms of like it's much simpler and much easier than relying on compiler experts, but it's by no means a solved problem. What we need is deep learning architectures that think like compilers. So whereas if you read a natural language from first word to the end of word of a sentence, you can basically understand the sentence. With a piece of code, it's not that straightforward. Open up some software project, you need to figure out you need to like jump between files, and source code itself does not read from start to end. There's this very well established, like rigorous formal system for data flow analyses in compilers, which basically describes how to reason about programs. And one of the things that I'm working on at the moment with my new colleagues is building basically an extension of graph neural networks that can match this, so they can start to, the way in which they process information matches how a compiler does. I think that's just one of the things that I think needs to be done.
Excellent, thank you. That's very exciting. Since I don't see any other questions on the chat interface, let's move on to something completely different. I think I should have mentioned this at the beginning, but the talks we are having today happen to come from all different areas of computer science, and they're all really great research in very different ways. So let me hand over the mic then to Rory, who just got his PhD from the University of Dundee. Rory.
Thank you. And I'll just share my screen. Hopefully you can see that.
Yes.
Cool, thank you very much. So, hi, I'm Rory Duffy, and I'm going to talk to you about my PhD research, Mining Ethos in Parliamentary Debate, supervised by Kasia Budzinska at the Centre for Argument Technology at the University of Dundee. So I'm actually going to start my presentation a little bit differently by talking to you about politics. So I think many of us would believe, or like to believe, that politicians are elected based on their policies and their arguments. But I think in reality, their personalities and character play a huge role. And actually, we saw this 2 nights ago with the presidential debates between Trump and Biden. But it's also a feature in UK politics. It's even a feature in the same parties in UK politics. And it's even a strategy that encompasses supporting other colleagues. It's definitely not a new strategy, going back at least to the 70s, and it's on our doorstep as well. So all of these strategies were actually defined in antiquity by Aristotle. So he came up with 3 modes of persuasion. That is pathos, the emotions of the audience, logos, reasoning and argumentation, and ethos, the character of the speaker. So there's been a large body of research in argument mining which looks to automatically extract one of those aspects, that is logos. And IBM have recently made this one of their new grand challenges in 2019 with the Project Debater. But what none of this research actually does is looks at the interaction between people. And so we need something else for that, and that's ethos mining. So the idea behind ethos mining in my research was to take parliamentary debates, specifically the transcripts of those parliamentary debates, apply natural language processing techniques to extract information, pass this on to machine learning algorithms, and then ultimately come up with a set of analytics. So the period of time I chose for this research was Margaret Thatcher's time as Prime Minister, where there was a lot of controversial issues going on at the time. So the first step then was to create a corpus of ethos. The idea is that you manually tag sentences with ethos supports, so that's supporting someone, and ethos attacks, attacking someone. And you can see here in green we have ethos supports, and in red we have ethos attacks. The idea then was to pass this corpus into a machine learning or into an ethos mining pipeline with several layers. So in the first layer we have modules that classify sentences as containing ethos or not using natural language processing techniques. And then we have a second layer which tags those sentences as positive or negative using machine learning and sentiment analysis. This work was actually published in the International Conference on Computational Models of Argument, where I won the Best Student Paper Award. And then it was subsequently improved in a paper to the International Joint Conference on Artificial Intelligence, which is one of the largest conferences in AI. The idea here was to use external data, things like Wikipedia, to extract lists of members of parliament and the prime ministers, and then use deep learning techniques again to automatically determine if sentences are supporting or attacking ethos. From that, then we can create ethos analytics as the output of that pipeline. The first step is that we can use the interactions between politicians to create networks. So here we have nodes represented as politicians, colored by their political party. And we have edges, which are the supports and attacks on their ethos. And what you can see is that politicians who have interacted a lot are pulled closer together. We also see 2 lines of politicians in the middle here, and these tend to be the ministers of each of the parties or the leading members of the party. The other thing we can do is create individual timelines and individual analytics. So if we take the average supports and attacks of someone's ethos, and then look at the standard deviation and see, or look at the spikes over that standard deviation and see if any of these spikes correspond to real world events. So in Margaret Thatcher, for example, taking those spikes, we can see that there tends to be spikes around the time she was appointed Conservative leader and when there was an impending general election. So just to try and close or finish my talk, I want to talk to you about the bigger picture for ethos mining. So in general, we already have argument analytics, so extracting arguments and producing live analytics. The idea then could be that we use this same idea and scale it up to ethos analytics, especially given that we have a continuing amount of data from the parliament. The other thing we can do is try and tackle disinformation or fake news by creating networks of people and seeing if what their reputation is. So I just want to close by talking about the outcomes of my PhD research. So I created the first ethos corpus, the first ethos mining pipeline, and the first set of ethos analytics, all of which I believe are crucial in understanding 21st century politics and beyond. Thank you.
Thanks, Rory, for a great talk. I still don't see any questions on the chat, so I'll jump in with a question of my own. Or really first comment, I found it really intriguing that you are using state-of-the-art computer science at investigating problems that have been with us since Aristotle and probably before. So my question was going to be, how might we better use your technologies to improve public debate?
So I think the answer probably lies in analytics. So a bunch of the work other work that we've been doing as part of the Center for Argument Technology is to try and produce analytics to summarize information in a way people can understand, and really show the arguments on each side. I think there's a lot of talk in the media and so on where you have comments from political commentators saying they think this person won an election based on them looking stronger, and they have no data or anything to back that up. So I think if we can use these techniques, pull out the data, and then they can use that. So it could be, in a sense, a tool for journalists to say, well, here's the data that backs up any of the assumptions I'm making about these people. And at least it's a bit more transparent for all of us as well.
Excellent, thank you.
Rory, I had a question. I mean, it's maybe a little bit
Stuart.
frivolous.
Yeah, sure.
But what do you think your system would have made of the Trump-Biden interaction of a couple of days ago? I mean, there's a slightly bigger scale question, which is, I think if you look at US politics and to some extent British politics, they've become more polarized over the past, say, 20, 30 years. And how would you see that reflected in the sorts of analysis that you're looking at? Because I think you say you had a much more consensual style in the US 30 years ago than you have now, which is a much more antagonistic.
I mean, I think despite the fact that we're slightly more polarized, I mean, it was still a tactic used back even in the likes of the 70s and so on, with Margaret Thatcher. So I mean, the focus of a lot of my research was in that area. And at the moment, I'm trying to scale that up. So looking at the whole of the Commons debates from 1901 right the way through to present day. And I think all that we'll see is that there's maybe slightly less, and I think that is the trend in the data. There are slightly less attacks on one another, and maybe slightly not as many supports either. And I think that's maybe because of what was acceptable at the time. And I think things will evolve. It could be that we're going through a particularly, as you're saying, polarized era, and eventually it will then calm down again once we get over events like COVID, perhaps. But you never really know. I hope that slightly answered your question.
Yeah.
Interesting, thank you. Every old problem is new again. Switching gears once again, let me introduce Yo from St. Andrews, who's going to tell us about his research. Yo.
Hello. Yes, thanks for the introduction and very great job from Chris and Rory. I'm Hui-Xiong Yo from University of St. Andrews, and my advisor is Professor Anne Quigley. I will talk about my PhD thesis today. So during my PhD, I have been working under the umbrella of improving mobile and wearable interaction, and there are briefly two branches. The first one is adding rich and expressive input to these devices, and the second one is supporting single-handed interaction. And my PhD thesis will be focusing on the second branch. And throughout the years, I am quite lucky to have many collaborators, and we have published some papers together. So for those that I'm the lead author, I have highlighted them in bold. The first research question for my PhD thesis is, how can novel sensing and input techniques improve single-handed interaction on both mobile and wearable devices? My approach to this question is by applying machine learning and deep learning techniques on the raw signal that are difficult to recognize using handcrafted features, but this feature can be easily learned by machine learning algorithm. And the second research question is how can off-the-shelf hardware and software facilitate the creation of novel sensing and input techniques for single-handed interaction? And my approach here is by repurposing existing sensors that are already built into the device, such as accelerometer and camera. So there is no need for new hardware, which can save cost and space. Especially this is quite important for small device with constrained space. So my thesis answered this question through the development, exploration, and evaluation of a series of new input techniques, which give rise to a series of research contributions, including some open source code, dataset, and patents. Let me give you an example. So the Apple Watch has a 3D touch features, which allows the user to press with different force. And it is quite cool, but it requires custom hardware. So I devised a new method to detect the pressure touch without requiring any new hardware. For example, if you can see the video, so user can press with different force, and the blue color bar represent the pressure that the user press. And this is all done without any new hardware. And the working principle behind this is quite simple. So imagine the watch face, the user pressed the watch face and it will be tilted. And by measuring the change in the tilt angle, we can infer the pressure level, whether this is a light touch or a strong touch. So this can be done without any new hardware. While working on this, I realized that essentially you require two hands to use the smartwatch, because one hand is wearing the watch, and what if the second hand is holding a cup of coffee, such as here? What about people with disability or encumbered? Also, what about using a large phone? Like a smartphone nowadays are getting larger and larger. It will be difficult to reach all area of the screen with the thumb. So I devised another method, which is called shape writing in motion. Basically, it combines a tilt with a gesture keyboard so that the user can tilt the device and control a cursor to perform gesture typing. As you can see here, the user can input text with only one hand. In another project, I used the Project Soli, which is a radar made by Google to detect hand gesture. And they have included this radar chip inside a smartphone. However, I use it for a different purpose, which is recognizing different objects and material. As you can see here, wood, plastic, glass, or glass with water, and all the stuff on the desk. But I will skip this part because I think the next part is more interesting. So we use the device and we can detect the different body parts. So here you can see we can detect the lower arm, the finger, the back of the hand to launch the clock application, the outerwear. And if the user is hungry, he can just tap the phone on his stomach. It will launch the food application, restaurant, shirt, or the pens for Google Maps. So all of this can be done with only one hand. Taking the same idea, although a slightly different hardware, user can also use the on-body gesture while on the move. So he can perhaps tap on the thigh or the belly to control the song, change the volume, or skip the next song. What about using hand posture to control device? So there is some commercial smartwatch with the side camera. As you can see here, it can see the part of the back of the hand. So using the same idea, we can also detect the different hand posture and use it to control smart devices. Very last slide. So using the same idea, user can also point at a smart appliance at a smart home and to control it using pointing and the hand gesture. So due to the time limit, I will stop here. Thank you for listening.
Thanks, Yo, for a very nice and quite a fun talk. So my question for you is, where do you think this technology is going next? I mean, you talked about a single hand things, but we can imagine perhaps even more on that line. So I wonder what your thoughts were on that.
Yes. A lot of my research are focusing on the techniques, but when you ask about the next step, I think it's a very important question, because next step is to make it more practical, because working with mobile device and wearable device usually is quite constrained in terms of processing power and the battery. So the next step naturally is to optimize them so that they can work requiring less power, less CPU power and battery power, and also make it more robust and stable so that it can be used in a real world.
Clearly lots of things to be done here. I see that Tim Storer has a question. So Tim, if you can unmute yourself.
Yeah, can you hear me okay?
Yes.
Yeah, it was a really interesting talk, as the previous two have been as well. I was wondering, would the technology work for, say, complex assembly tasks? You know, maybe somebody's putting together a piece of equipment with various parts, and could the technology detect the different parts so that, you know, if I was putting the correct parts together, the shapes would be detected by the radar system you've got?
Yes, that was one very interesting use case that we also discussed in the paper, like including a recycle center, sorting waste, and also assembly tasks in the factory. So perhaps using only single modality, only one radar, maybe it can't be 100% accurate for the detecting the object. So maybe it can be combined with multiple sensors, multiple modalities, including infrared, to improve and make it more robust. But the radar can be the major source of signal. Yeah. Does that answer your question?
Yeah, I was wondering, do you have plans to, you know, begin, you know, building applications of your research rather than pursuing the, you know, one possible direction is pursue further research explorations, and another is to sort of begin exploring applications and spinning out or something.
Yes, definitely. I'm interested in exploring the real world applications, but it also depends on my next job. So I'm also looking for a job. So yeah, so yeah, it depends.
Definitely.
Thank you.
You do wise to snap him up.
Indeed.
Moving on then to Babis from the late of the University of Strathclyde, who's going to tell us about his research on something different again. Babis.
Can you hear me?
Yes.
Okay. So hi, my name is Babis, and I will introduce you to my research, which was about a digital educational tool for younger children with type 1 diabetes. The project was conducted in the University of Strathclyde, and my supervisor was Marilyn Lennon, who I want to thank for her help and support throughout the project. So the problem with type 1 diabetes for children is that it's a very hard condition to manage, especially for younger children. And currently the education targets only parents, and there is no formal education for the younger children. So these facts combined shown that lead to serious long-term health complications due to the lack of knowledge. So similar work has mostly focused on educational video games, mainly for children older than 8 years old who already have literacy skills. Almost all of these video games focus only on the management aspect and not the basics about the condition, and all of them are outside of the current care pathway. The methodology I used in these projects was an adaptation of the human-centered design process. So it comprises of the following 4 stages. The first one was to understand the context through interviews and observations. The second one was to using the previous stages outcomes to specify requirements for the tool. The third one was to co-design with clinicians the tool and build an actual working prototype. And the final stage was a large-scale evaluation in context. So throughout the project, 9 healthcare professionals, 27 parents, and 21 children were involved. The idea behind the tool that I built was to empower clinicians educate children by enhancing the existing approach of the clinic through interactivity. Hence, I built upon an asset used by the clinicians, the plastic food toys shown in this image, which are used for illustrating different categories of food to the children. So the system looks something like this. We have a main station which hosts inside a projector and also a mirror. So the projector projects through the mirror to the back screen. And also we have plastic food toys and a plastic insulin pen, a fake insulin pen, both with RFID tags embedded. Behind the screen now we have sensors, RFID sensors. So the plastic food toys and the insulin pen can interact with the screen, so children can feed the wee character you see on the screen and provide insulin in order to learn more about diabetes. That's how the tool looks like. You can see it on the right. And on the left, you can see the plastic food toys, most of which I also built myself. Just to mention that this tool was designed for children between 5 and 9 years old and does not require any literacy skills in order to play with. Moving to the final evaluation, it was conducted inside the clinic with through 5 sessions with 4 clinicians and 17 children and their parents. In terms of measurements, I measured educational effectiveness, feasibility of adoption, and age appropriateness of the tool. The results pointed that the tool was effective in conveying the educational message. It was age appropriate and enjoyable, and was perceived as feasible for adoption. When it comes to outreach, 3 academic papers have been published, one of which was in CHI 2019 here in Glasgow. As for the future of the tool, I am considering a standalone tablet version of the tool so that children can continue learning at home with it. I also am considering the use of the tool in other settings as well, such as schools where children with diabetes can educate their peers about the condition. Also use the tool for other age groups such as older children or adults. And finally, even use it for other food-related conditions such as obesity. So with this, I would like to thank you very much for listening, and I'm happy to answer any questions you may have.
Thank you, Vavis. That was a really good introduction, and it was really nice to see such a novel application.
Thank you.
So my question that I had was, I mean, it was obviously you validated this with the children who are undergoing this condition. Was there also perhaps some indication that this could help parents deal with what I would imagine would be quite an unusual situation, quite an unknown situation?
So as I mentioned in the beginning of the talk, currently there is no education for the children. So the parents have to educate their children, and they have a multiple role to play as parents. They have to take care of their children. They have to take care of their condition and manage their condition. They have to cook specific food for them. They have to measure. So they have to do a lot of things, and it's very, very hard for them. Absolutely. So by alleviating some pressure for them and educating the children inside the clinic through the tool was one of the things that really the parents enjoyed and liked, because there were many things that they couldn't explain to their 5 or 6 year old child about diabetes that the tool gave to the children a better understanding of these complex problems. So I think, yes, it can really help parents as well.
Excellent, thank you. Okay, if nobody else has a question, I'll next hand over the mic to Gazelle, right, of the University of Glasgow, who's going to tell us about something to do with driving. You're muted, Gazelle.
Yeah, exactly. Sorry. Hello. Thank you very much for having me on today. So I'm Gazelle. I'm from the University of Glasgow, and I'm going to present my research on multimodal feedback for mid-air gestures when driving. So mid-air gestures allow drivers to control in-car systems without taking their eyes off the road. This has the potential to minimize distraction and improve safety by replacing complex actions, such as precisely selecting buttons on the touchscreen, with simple hand movements in mid-air to reject a phone call. However, mid-air gestures lack critical clues, which are essential in human-computer interaction, which is feedback. Feedback is absolutely necessary if gesture interaction is to be successful. Current mid-air gesture systems in cars only give limited and mainly visual feedback on the center console. However, if drivers need to take their eyes off the road in order to understand the interaction with the car, then the benefits of gesturing in mid-air are not being fully realized. Further, gestures are generally prone to usability challenges, which cause frustration and workload. Good feedback can overcome these issues. Feedback informs the user whether the system pays attention to them, whether the user addressed the system correctly, and whether the user's intentions were understood correctly by the system. Multimodal feedback is when information is presented to multiple sensory channels at the same time, such as information is presented to the tactile or the touch channel, the information is presented to the auditory channel or the olfactory channel. So basically presenting information to multiple sensory channels at the same time. And a plethora of research has shown that multimodal feedback is beneficial for non-driving related tasks, such as infotainment system in the car, and it is very beneficial for gesture interaction also, to understand what the system is understanding of my intentions. Therefore, my work investigated the design and the evaluation of successful multimodal feedback for driving scenarios. 3 novel feedback types for mid-air gestures were investigated to address and minimize visual distraction, mental workload, and user uncertainty without negatively affecting driving nor gesture performance. Those 3 novel feedback types were cutaneous push, peripheral lights, and ultrasound haptics. I will present all of them one by one. So tactile feedback is a core part of providing a sense of agency, a sense of control over the gesturing system, whilst also reducing the eyes of the road time. The cutaneous push steering wheel that we've developed, as can be seen on this video, provides information to the driver via 3 solenoids under each palm that push against the driver's hand. Cutaneous push therefore delivers rich messages which maintain high spatial accuracy and conveys robust cues which are unmistakable for in-car vibration, and they can be presented very, very quickly because they just pop out. These information are very important in driving environments. Peripheral light feedback was displayed on a single LED strip from the A-pillar to the center of the console. The strip was placed behind the steering wheel where the instrument cluster would be, as can be seen on this image here. And the benefits of peripheral lights for in-car interaction are that it does not interfere with the primary task in demanding environments, such as been shown in aeroplane cockpits, and it is a very effective solution to convey information in data-driven environments to no additional cognitive demand. And finally, ultrasound haptics is an alternative feedback modality for message delivery to the hand. Focused ultrasound creates areas of acoustic radiation pressure which make haptic shapes and patterns perceivable on the skin of the hand. The benefits of ultrasound haptics are it provides information to the unadorned hand in mid-air, it increases the sense of control for the gesturing driver, and it reduces visual distraction during the gesturing interaction. And in our studies, the ultrasound array was placed where the gear stick would be. And prior to this work, the impact of ultrasound feedback for gesturing had not been investigated, neither on driving performance, visual, nor cognitive distraction, which was and is a very, very timely problem, as production vehicles such as BMW and Jaguar Land Rover do use these devices in their gesture interaction in their current in-vehicle systems. The 3 feedback techniques that were developed and investigated here were tested and analyzed in 7 different studies with those 3 gestures presented there, and we've tested them on 120 participants. our results were that cutaneous push feedback is a very effective very effective way of message presentation with a very high user acceptance, and that the feedback types, despite being low in resolution, supported gesture interaction, especially when combined together, even during more challenging driving. The impact of this research was that we've published 7 papers with almost 80 citations by now, and the work and the novel feedback techniques presented here have had real work implications, as they have reached researchers as BMW and Jaguar Land Rover, who have implemented our feedback techniques into their current in-car systems, and also have dialed down on their promises regarding certain feedback types, such as the ultrasound haptic arrays, which we have shown is medium good. So basically, this research has contributed to making driving to some extent safer. And other researchers have also picked up, for example, the cutaneous push feedback and have embedded it in the armrest for the driver to inform them about approaching cyclists. This is very exciting for me personally. Finally, many, many thanks to my amazing supervisors who have given me unfailing support. And that's me. Many thanks.
Thank you, Gazelle. It's great. So I can certainly see myself using some of the technologies you described. My question was, have you thought about how this might generalize to similar related tasks, perhaps something like HGV or truck drivers, or going further afield in airline cockpits or ship cabins or things like that?
Well, as long as the tasks are non-essential, I don't know, there is a better word for this. Non-critical. As long as the tasks are not critical, gesture feedback is absolutely 100% doable in any kind of environment, especially in demanding environments also. However, the problem with gesture interfaces at the moment is that they are very prone to usability challenges. If I swipe around, I mean, Yo probably knows this problem also in his research. When he would swipe around, the interface might not always recognize the swiping, which worst case scenario can increase mental distraction. It can increase eyes off the road time also, because then the participants take their eyes off the whatever is going on the road to try to figure out what is happening on the center console, or actually even towards the gesture interface, trying to figure out why it's not understanding the gestures themselves. So for non-critical tasks, I absolutely think that gestures can be taken up into trucks and lorries, etc. However, also feedback is very, very essential. Without feedback, as I said, participants do take their eyes off the road to try and understand what is happening. So it is very essential that feedback is presented to non-critical interactions.
Thank you. So if there's no further questions, I'll thank all the speakers again. It was all really great research. Alas, only one of them can be chosen to be the Best Dissertation Award. And to present that, I'll hand over to the SICSA director, Stuart.
Hi, I'm Stuart Anderson. I'm SICSA director, and actually I get the great pleasure to announce the winner. Yeah, but the award will be done by Ben Allison from Amazon Development Center, who've sponsored the prize. And we're not going to count down from 3, 2, 1. We'll just go straight to number 1. So the winner is Chris Cummins for his thesis entitled Deep Learning in Compilers. And congratulations. I would say that you were all reviewed extremely highly, and it was very, very close run thing. So Chris just shaded it at the final step. So
thank you.
Anyway,
thank you
congratulations to all of you. It really demonstrates the excellence of PhD work going on inside the SICSA member institutions. So thank you very much for all of those talks today. And I'll hand over to Ben.
Thank you very much. Great to be here. Thanks so much for the invitation. My name's Ben Allison. I'm the principal machine learning scientist with Amazon at the Development Center in Edinburgh. working on a bunch of different problems. So my main focus today is a product called Sponsored Display, which is an advertising product that Amazon builds worldwide that aims to allow, all of the different sellers and vendors on Amazon to do advertising, kind of awareness style advertising. And as I say, that's a kind of worldwide program that's run from the development center in Edinburgh. But I want to congratulate Chris and indeed all the participants and say something about why I think this kind of work is super important, both the practice of getting a PhD and what that brings to you, but also the way that we use science and machine learning at Amazon to drive customer experiences. So I think I'm somewhat qualified to say that. A few years ago, I myself got a PhD in natural language processing and machine learning back before it was cool and it's what everybody was doing, and before it was powering large amounts of the internet and everything else in modern life. And for those of you that are still studying, and those that have completed as well recently, I want to say that I think this kind of study is super important. It's strategically important to Amazon that we have these kinds of relationships, but it's also super important and useful for all of you. I think there's a temptation to somewhat unfairly characterize PhDs as going ultra deep on some very specific problem that about 5 people in the world care about, and then once you're done with it, you forget about it and move on to other things. Obviously, that's not true. That's not always true. There are certain kinds of very specialist disciplines that turn out to be quite useful in the real world, and I'm an example of that, where machine learning has turned out to be much more useful than we thought it would be when I was doing my PhD. But there's also a bunch of transferable skills that I think everybody should think about and try to develop while doing your PhD. So that's things like how to take these super ambiguous problems that nobody knows how to solve and make progress on them, and not be intimidated by the fact that you're trying to do something that hasn't yet been solved, and the kind of perseverance and grit that goes along with that. And also things like presentation and communication skills, where you focus on taking these super complicated concepts and boiling them down to their essence, as was so well demonstrated by the speakers today, boiling them down to their essence so that in a few slides and a few minutes you can explain it to, maybe not quite a layperson in the case of this audience, but sometimes even a complete layperson or someone from a completely different background. And I'm really happy to be invited to present the work to Chris. It turns out, although I wasn't involved in making the decision, that Chris's work is a great example of one of the principles by which we organize teams at Amazon. So a lot of research in academia follows this model that you might call curiosity-driven research, right? People look at the literature, they understand what other people have done, they spot an opportunity to maybe advance the discipline a little bit, and knowledge is accumulated like that, and occasionally something surprising will come out of that process, and we'll figure out something that's applicable more broadly, or to a domain that we weren't anticipating when we started the research. But the way Amazon thinks about these problems, and I think it's it's something that allows us to kind of move very quickly and do a whole bunch of interesting stuff in many different disciplines, is something that we in the science community have been calling customer-focused science. And what that really means is starting from the customer. Like, this is an Amazonian principle anyway. You start from the customer and work backwards, right? So you think about, who is my customer? What problems do they have, or what opportunities do we have to make the world better for them? And then work backwards to the technical and scientific problems that you need to solve in order to enable that experience. And that kind of work is powered by these sorts of cross-disciplinary insights that I think Chris's thesis is a great example of, right? So taking machine learning and deep learning and figuring out how to use it to optimize compilers, and you know, in quite a different way. And so that's, you know, a huge benefit. That's a huge benefit of acquiring deep knowledge, is you can often apply it in surprising ways to domains and disciplines that you didn't first anticipate. So that's really all I wanted to say. Thank you very much for the invitation. Congratulations not just to Chris, but to everyone who was nominated. Looks like it was a very difficult decision, and the talks were all super interesting. But yeah, Chris looks like a very worthy winner, and we're more than happy to support both Chris and the organization as a whole.
Thank you very much, Ben and Stuart and Susmit. And yeah, I really enjoyed all the talks. I thought it was really super cool. Yeah, great work. Thank you, guys.
That's great. Thank you very much, and congratulations to everyone. Okay.